12 dB is a measure of the antenna strength, the amount of gain the antenna provides you. The current one is mounted at 5 meters in the air. That will become important shortly. A couple other bits of information there. And then we have this. We have a synced miner. What this basically means is that I can recognize you, you recognize me. The two miners are kind of waving at each other from across the way. The data itself might be good or might be corrupt, not working so well, depending on a whole host of factors. But it's saying that at least I see you, you see me, we recognize each other. We know you're there when one miner is synced to the other. This transmit scale, if I understand correctly, is a measure of efficiency, meaning that what we want to shoot for is 1, and so this one is less than optimal. And I think it basically means that you may have a cell overpopulated or saturated with too many miners. Now you still may be making money with this miner, but I think it's telling us that the same amount of work could be accomplished with 1 less miner, or 2 less miners, or 3 less miners, depending on how crazy people have been in putting these anywhere. So if in this situation, you might be better to move this miner to another location if the others can, if you own the others and they can handle the workload. Helium pays in their own cryptocurrency, or in a cryptocurrency. It's named HNT, and that can be converted to US dollars. 33 at this. And that's tracked over the last 24 hours, 7 days, and 30 days. Let's see, over the 30-day trend, this miner has earned 26.7 HNC tokens, and that translates to 538 US dollars. Quite a tidy sum. If we get some of those, that'd be great. Okay. And from that cell where the gazelle resides, you can see that the yellow lines represent communications between 2 miners, or at least 2. So Daffodil Gazelle can communicate with this guy, and all these here with the yellow dots. You'll notice in some situations it can communicate with one that's further away than it can with this one, where it's not communicating, even though it's closer. And there's a whole host of reasons that could be, but we'll get into those. So I like this helium tool for the visuals. It's not, one problem with it is that I think it plots all the miners right in the center of the cell, even though that's not going to be accurate enough for our purposes. Now these cells measure about 1.1 kilometers from point to point, so 1,100 meters. And there's a sweet spot that these miners operate at. The minimum is about 350 meters, and the range will go up to maybe 650 meters, somewhere around there. So we want to place them somewhere within that window for best operation. It's probably obvious to you that if miners are too far apart, their signal strength decreases and you lose communication. So we would want to avoid that, of course. But it may not have been as obvious that you can have miners that are placed too close together, where they swamp each other, step on each other's toes, so so on and so forth. And so that's why we want a minimum of 350 meters between miners. Now this cell size works out rather nicely, I think. If we had a miner at close to one point and another at the far point, we could place one right in the middle comfortably and would do quite well. Or if we had two, one at a point and one in the center, we could go to the other far point. So that's going to give us about, what, 550 meters would be the center. And that's part of the evaluation we want you to make. We'll get a desired location, but then we'll need to prove out that it's going to function properly. And so depending on where existing miners are already in that cell, you can make a determination whether another location might be better or whether it's not worth doing at all. Okay, let's flip over to the Hotspot RF tool. So here's the home page, Hotspot RF. If you click on Portal, I think this software was developed by guys in San Francisco, so it always opens there. Just takes a few seconds. You'll need a login. We'll send you that in an email.